Hi, everyone. Thank you for joining our Elastic community meetup today. A little bit about me. I am the specialist for Elastic community programs in APAC. Today, joining us is Johnny from Confluence, who's the senior solutions architect with them, and our advocate from Elastic, Ashish Tiwari. They will be helping you out with the questions at the end of the session. Please note that the session is recorded. We have started the live transcript for anybody who's unable to hear, as well as there would be the presentation shown on our website later if you need it for any reference purposes. Something about the Elastic user groups. We have about 157 chapters worldwide. We are always looking for organizers who can come and join our group. They present. They're a part of our great contributor program, which you can get more details from here. We have our Slack workplace where you can connect with us, YouTube channel where you can see the session later, as well as we have technical forums, which is the discuss.com, where you can post your questions and somebody from Elastic who's a specialist will answer your questions. As well as we have this great APAC virtual user group that you can join. We are hoping to see you there soon. The Elastic Contributor Program that I was talking about. It's a great program where once you've contributed in any way to Elastic in terms of either code, or you have written a blog about Elastic, or for example, you have run a meetup for us, you will be able to sum up those points every time you contribute to us. And there are awards in the end. You can read more about this program if you scan this barcode on your phone. Please reach out to us if you have any kind of questions whatsoever about it. Good thing we wanted to discuss with you also is that we are hiring. These are the current positions at Elastic. You can apply for
Cornish, any. I'm sorry to interrupt you. I think the screen is not shared.
Oh, shoot.
No, not an issue.
Oh,
you can continue from that QR code slides. Before that, we are pretty clear. So, yeah.
It's a good thing I can edit this one out. So
yep. Great.
Let's see. How far did we actually end up doing this? Let's go back a little bit. Alrighty. So are you able to see it now?
Perfect.
Okay, awesome. Again, the QR codes are here. There's the Slack workplace for you to chat with us. Our YouTube, our technical forums where you can ask us questions, as well as the APAC virtual user group, which is at the end. Please join us. And yes, the Elastic Contributor Program, that's the QR code for that one. For awards, any kind of contribution, please scan the code. Please get in touch with us for any kind of questions. And yes, we are hiring for technical consultants, solutions architects, for ANZ India, as well as the Director of Support, which is for services team. You can find and apply for these positions at our Elastic website. If you scroll down all the way at the bottom, you can actually see we are hiring. If you have any questions, please post over there and our recruitment team will get back to you. Thank you. And yes, you'll get a free cloud trial, which you can scan this code and get. In case anybody has missed out on any of the QR codes, I will put this up on the page where you've registered for today's event, and you can actually get it from there as well. And moving on to the exciting today's session, which is with Confluence, Johnny Mirza, who's the Senior Solutions Engineer at Confluence. He is going to introduce you to the topic, which is how to modernize your SIEM with Confluent and Elasticsearch. So over to you, Johnny. Thank you.
Awesome. Thank you for that intro. So I'll just share some slides and please keep this interactive. It's really for you guys, so happy to answer any questions along the way. So just a little bit about myself. So I've been in the IT ops security space for quite a while now. So I've been working at, prior to Confluent, I was working at Splunk for 4 or so years. It's a pretty good company to work for at the time, and I guess, yeah, that's a little bit about me. And working with some of my customers, I kept hearing in the landscape, they're all, you know, a lot of them were asking, you know, we're doing so much stuff with Kafka. Why don't you guys have some sort of Kafka integration or Kafka as part of your solution? And I kept hearing that over and over again. And here I am at Confluent, which I'll talk to you about. Who is Confluent and how are they related to Apache Kafka? And I'm here now for a year and a half working and specializing in sort of the SIEM modernization space and the IT operations and metrics and observability space. So that's a little bit about me. Please feel free to reach out and ask any questions along the way as well. Just a high level agenda. We've got a fair bit to go through today. So hopefully we can get through all of this during the session, but happy to schedule something later as well. But really want to talk about what is Kafka. Let's go back to basics and figure out what is Apache Kafka, why was it created, and who is Confluent as well, and what's the story behind Confluent. Then I want to talk about Kafka specifically for security and how we can use Kafka to enrich or enhance some of your security operations and SIEM use cases. Also some advanced techniques around Kafka streams processing and using the open source Sigma signature profiles to be able to run real-time detections in Kafka streams for all of your high priority and real-time searches and detections. If we get time, we'll jump into a demo. We've got a great demo and also a recap as well. Okay. All right, so what is Kafka? Little bit of a background. Kafka was created back at LinkedIn. It was founded in LinkedIn back in 2010, 2011. And it was really created because there was lots of data and lots of databases specifically that created data, but they were very siloed and they're very point-to-point sort of communication every time you wanted to get data from those databases. So the creators of Apache.
Hi, Johnny. Sorry for interrupting. I think screen is not shared.
Oh, really? Okay. Sorry, my bad. I just did exactly the same thing. I
Not an issue.
did that. I thought I did that. Okay. Let me take a step back.
Cool.
Is that better?
Yep.
Seems like a screen sharing problem today. So yeah, just to recap on the agenda. So we'll go through Apache Kafka overview. We'll talk about Kafka for security. We'll talk about some advanced Kafka stream processing security use cases using Sigma Prime, Sigma open source signatures, and then we'll go through a demo and recap. So hopefully my screen's shared, but Kafka is really these three things, and it was created at LinkedIn to solve a problem around data integration, essentially. So lots of databases, for example, would create, every time you updated a table, it would store data in a log file, in a redo log file, for example, or some sort of log entry. There was obviously log systems out there creating log files, generating syslog messages, lots of different integrations at the time. And trying to get access to that data was really complex and difficult. There was a concept of message queues at the time, so produce and subscribe, or publish and subscribe to data. So publish to get data and then subscribe to that data. And they were part of the integration life cycle, or the integration chain there. But what would happen is once you subscribe to the data, you would basically lose the source, right? So you would basically, the data is very ephemeral. So Kafka was created on the premise of an event stream or a store of data or a log of data. So you would produce data into a log file, which would persist the storage or the data onto a log, and it would tag the data essentially with some metadata, being an offset and some timestamp information there as well. So now you can publish data into a log stream of information, and then you can subscribe to that data many, many times, rather than sort of a message queue where you only subscribe once and then the original message was deleted. So they're really the two core things that you probably know. Everyone kind of knows that from a Kafka perspective. But the third part that's kind of unknown is the stream processing side. Being able to process that data while it's going from produce to subscribe, or from source to sync. So being able to run stream processing, which we'll look at today, how to run some enrichment, some ETL, some aggregation of your data, and even some advanced use cases around running security threat detections in real time on top of the stream processing engine. And if you look at the log file, this is typically what a log file looks like. It's a log file like any other log file that you'd see in an IT system or a security system. It's a file that's written to disk, and it's got a historical record that's tagged with a sequential number being an offset. And an offset is how Kafka monitors where the applications are up to, specifically in a particular log file. And when a particular consumer or a new application needs to read from that data, it will consume from a specific offset that it was up to, or from the latest offset, in this case being 12, you can consume that data in real time. And it's based on this premise of really storing that data for long periods of time and being able to consume that many, many times by many different applications. Let's check that. Okay. And from a Kafka perspective, and some of the challenges, and this is where it complements a lot of the SIEM providers as well, and a lot of the operational tools, is Kafka does handle massive throughputs of data. So if you look at your Netflix, your Uber, all those large enterprises, most of them are built on top of Kafka. And that's from more of a business application or a front-end application. If you think about that from a security context or an IT operational context, it really helps funnel through lots and lots of data to be able to run better enrichment, better real-time detection, and handles massive amounts of data with a smaller amount of nodes. And the way it scales is horizontal as well. So it'll scale up and scale down as needed, and it can be very flexible in that regard. More from a database perspective, but also very important from a security perspective in terms of fault tolerance and data persistency, but being able to make sure that messages come in order, they're always ordered, and they're always fault tolerant as well, so which is really important. You don't want to lose messages. You want to make sure that messages are correctly written, they're acknowledged, for example, they're read exactly once. So having that distribution guarantees built into that Kafka is by default is built into that design. And also I mentioned the rewind and replay. This is a really good function. It comes back to that commit log. So being able to replay the data many, many times and only produce once. So they're the key characteristics. Now, if I take a step back and talk about, well, who is Confluent? We spoke a fair bit about Kafka. So I mentioned that Kafka was founded in LinkedIn. It was created in LinkedIn. And then LinkedIn open sourced Apache Kafka to the Apache Foundation shortly after. And the actual founders or the creators of Apache Kafka went along and started a company called Confluent in 2014. So Apache Kafka, the founders are still with us today. So most of those committers are still with Confluent at the moment. So 80% of all of the commits, all of the committers come from Confluent. Even for the open source scenario or the open source Kafka, most of those committers do come from Confluent. And if you think of it from a support perspective, I imagine it's very similar to Elasticsearch, where Elastic has its own committers that commit back to open source Elasticsearch, and it's very similar from a Kafka perspective. Confluent is the key contributors back to Apache Kafka. But on top of that, we extend our capability to provide features and functions that allow Kafka to be more enterprise ready. And just to give you an example, everything down the bottom in the blue, the dark blue there is Apache Kafka. You can go and download that. It's all community licensed, it's open source. You can run that right now in your own environment. It's all based on sort of Java and Scala to be able to integrate with open source Apache Kafka. And then you can see some of the Confluent features and functions that we offer around Apache Kafka to make it more enterprise ready. So things like non-Java clients, a rich ecosystem of connectors, which we'll talk about, obviously Splunk and Elasticsearch today if we get time in the demo, a whole range of monitoring operational tools, things around audit controls and audit logs and role-based access control built into it, and even sort of global resilience around multi-region clusters or replication between multi-site deployments. One of the key things I also want to talk about today is KSQL DB, the event streaming database. And that is the engine, essentially, that we will be using to run the stream processing on top of the data there. There's 120, 200 plus connectors now that are pre-built to integrate with all of the different systems. So not only is it from a security or IT operational use case, but also a lot of the data that goes into these security systems is, and when I was working back in my old role, I would hear customers saying, you know, the marketing team wants access to this data, or the billing team wants access to this data. It was really valuable data, but it typically used to be owned by one team, and it was very difficult to get access to that data source. So when you think about it, some of the syslog data would be really important to sync that to something like Snowflake, which would be useful to run reporting on top of that data as well. So Confluent has a whole range of these connectors built in, and strategic partnerships with companies like Elasticsearch there as well. So if we jump into the security side, why do we see a lot of customers? We're hearing lots of customers starting to talk about augmenting or optimizing their SIEM platforms with Confluent and Kafka specifically. And it really comes down to, and we'll talk about this more, but a lot of the SIEM operated tools are still very batch in focus. So for example, you would run a search every 5 minutes or every 30 seconds to spin up a dashboard. And that's kind of like a micro batch or a batch process that needs to run that service. And we're starting to see, especially in the security and the operational use cases, that threats are becoming more real, and we need to be able to action and triage those threats and detect those threats in real time and at scale. We're starting to see customers be using Kafka for those sorts of use cases. We're also seeing that sometimes some data is not as important as other sets of data. There might be a whole range of data that is, informational type logs that is not as important as error logs. So using Kafka or Confluent to reduce and filter out some of that data, but also aggregate it and keep a record of that data still existing, but also reduce some storage and licensing costs there as well along the way. And also enabling that flexibility of choice. So for example, in the demo today, if we get time, I've got an example of Splunk, taking Splunk data from Universal Forwarder and then doing some filtering and enrichment on that data and syncing that to Elasticsearch, which is a really good use case there. But also, as I mentioned earlier, it's not just about taking from one tool to the other, but also making that data available to the rest of the business that needs to have access to that data or wants to have access to that data in a secure fashion. If you think about it, a typical SIEM platform looks like this, or a IT operational platform looks like this. You'll have some proprietary forwarders or agents or collectors. You might have some integrations with, syslog and those sorts of engines there. There's database integrations potentially, or CMDB or asset and ownership type information. But typically there's a proprietary agent that is bundled into the collection there that kind of makes it difficult and sticky to the specific a specific vendor, and a lot of times they're not open source in terms of that collection method. And everybody has their own way of analyzing and monitoring and searching data. There's obviously schema and read. There's database type messages. There's document stores. There's lots of differentiators there when it comes to being able to search and report on top of that data. And if you look at it, this slide was actually taken more from an application perspective. So really it's come down to a lot of the requests that we're starting to see is really batch type processes. And if you think about data at rest, where something's written to a database or it's written to a log system, and then there's some sort of slow batch process that needs to consume that data. And it's just not in real time. And then the other thing is you'll find out that a lot of the batch processes are also chained together. So one batch process is also waiting for another batch process to finish before it can consume and get updates to that specific data source there. Okay. I think we had a question there. Yeah, absolutely. If there's any questions, please feel free to ask in the chat along the way, or happy to answer that if you want to go on mute, absolutely. And when we take the scenario and we start to look at how does this look in the Confluent scenario, in the Confluent world. So now we've got a streaming pipeline that basically can take data from lots of different sources, whether it's things like Splunk forwarders, whether it's different formats as well. So NetFlow, Zeek type data, whether it's protobuf data sources, whether it's got a schema or it doesn't have a schema, whether it's metrics formats, being able to collect that data in many different ways. Kafka is very good at being able to stream that data and collect that in real time. in a highly scalable and efficient manner. But then being able to run all of your real-time enrichment, routing, filtering, even use cases around machine learning and AI on top of the data in real time, whether it's it's running those real-time alerts in Kafka streams or in stream processing. You might have another data warehouse or another Spark type system that is doing the training and modeling, but being able to run that detection in real time in Kafka streams. And then obviously being able to sync that data to the right tool for the specific department. And this is really important where I've seen in large organizations, you've got 2 or 3 different service providers that are providing a service to a business. One of them might have a tool of choice, the other one might have another tool of choice, the other one might have an IT operational tool that they need to get access to the data. So it's about being able to share the data with the right tools in a controlled fashion, and then improve the quality of detection and optimizing a lot of the use cases when it comes to SIEM or IT operations. So when we look at some specific use cases, using Kafka and KSQL DB, so Kafka's got an engine that has a stream processing built into it, and you can see it's using a SQL-like language. So we'll go through that in detail, but being able to aggregate, join, filter the data, trim out sort of large events that are not needed, so large JSON events or large XML files, for example, being able to just pull in the specific data that you need, and then reduce that sort of message size and make the SIEM ultimately be more effective and efficient in terms of searching and running data across that. So being able to use Kafka to trim out some of those events is something that we see quite a bit. And also, as I mentioned, running real-time detections and running real-time sort of analysis or predictions on top of the data as it's running through. So typically, for example, you'll have data as it stores messages in the log. You would have a consumer that is consuming that data for model building, and that could be something like Spark, or it could be a TensorFlow or something that's running that training model. But then you would run the model against the ML app that runs in-stream to be able to run that real-time analysis and detection on top of that data there as well. So I mentioned KSQL DB. I just wanted to show you a visual sort of representation of how KSQL DB works. It's really about real-time aggregation of data or real-time stream processing of data as it's flowing through from source to destination. So you can see here an example where it's running a function. So it's looking for readings that are above a certain level, and there's a range of conditions that can be run and met, and then written to another topic to be consumed by an upstream consumer. So there's, you can see there that there's joins, there's connectors that are running to this particular K-Streams application, and being able to create a simple query to be able to create a new stream of high readings where anything's over 41 in this particular case. Now, I just wanted to share a little bit of reference architecture as well. This is more from a Splunk perspective. So obviously Splunk has universal forwarders and they've got their own agents and heavy forwarders to collect data. So that they've got their own source types. They collect syslog or Windows event logs or any of the data that's coming through. So Confluent has a Splunk to Splunk connector. It's a source connector. So it's a producer that basically collects data from universal forwarders. So you point the forwarders to the Splunk to Splunk connector. That will write it to a Kafka topic, which gives us the ability to run real-time stream processing on top of that data, whether we're enriching that data with an CMDB or with another data source, and then being able to sync that data to the relevant team. So whether it's Elasticsearch or S3 or Datadog or Google Cloud Storage in this particular case. Or you might even want to sync the data back into Splunk there as well. And likewise with Elasticsearch, it's very similar. So there's deep integration with Elasticsearch with both Beats and Logstash to be able to have both source and sync connectors from a Logstash perspective. But consuming that data, correlating that data from a log perspective, creating that materialized view, which is essentially the aggregation of the data that's flowing through the system, and then syncing that back to the right Elasticsearch index for the right user group to consume that data. So I just want to touch on the last thing, and this is from a security perspective. So Confluent's been working on an open source project. You can go and download this now, and I'll share the material. But this works with Sigma, which is a generic open source signature format that is written as a marketplace for that called SOC Prime, where you can go and download these signature formats for following the modern attack framework, for example, to be able to run any sort of real-time detections in Kafka streams. So what we've built is a processor that can take these YAML files, these Sigma files, and run that detection in real time, write it to another topic, and then we can run that. That can be synced up to a SIEM tool like Elasticsearch, for example, to be able to triage that data. That's a really sort of fast way of doing this. And there's also a really good regex extraction engine built into the Sigma processor. Just go with time. So I won't go into this in too much detail, but I'm happy to share this. But this is what a typical Sigma rule looks like. It's basically a YAML file that you can upload. It's got some conditions, it's got a selection, it's got a pre-selection, and it basically matches that condition together. So in this particular case, it's looking for HTTP post or put where it's a non-ASCII character. So being able to run that detection in real time, we can see the specific source of the data is Zeek HTTP, and it's looking for a specific method, which is a field, and then it will look for that regex to say if it's a non-ASCII character. If it does hit that condition, then it will write it to another topic. And so this is basically, we'll go through some of this, but it's essentially a Sigma rule with aggregation. So it's looking for that condition or a condition again, but it's also doing an aggregation by the origin host or the IP address where the count is greater than 2. So it's actually running some aggregation on top of that data. It's also running it within a minute time span. So for example, you might have a whole range of denied access or failed logins, or in the credit card world where you can see a whole range of credit card information or failed attempts within a 5-second window. You could look at running a Sigma rule or some sort of processing and run that in Kafka streams as well. So from also within the Sigma rule is a field mapping sort of engine here as well. So you can map sort of fields to the different fields within the log file. So a good way of sort of keeping that information model up to date with the different field types and the different sources coming through. And we've also built a little UI for this as well. So it's just kind of like a proof of concept. It's just there just to show you the flow of this. It's all built on top of Kafka, but there is just a UI just to show you what that looks like there as well. All right, so just seeing how we go for questions and time. I think everything's looking good. I might jump into the demo. So here's what to expect. So in the demo, we're actually using an event generator that's replaying some data, which is some Cisco ASA data. It's running within a Splunk universal forwarder. That universal forwarder is already indexing the data into Confluent using the Splunk to Splunk connector. And what we want to do is we want to look at how do we aggregate some of that data within the Splunk instance, and then how do we sync that data over to Elasticsearch once it's being aggregated. And then also we want to look at some stream processing. How do we run some stream processing, some of those Sigma rules in real time? All right, so let me jump into my screen here if you guys can see that. It's jumping into a demo. I'll zoom that in. So everyone can see that okay? All right. Now this is Confluent. It's kind of just running on my desktop, so my screen's a bit widescreen here. Happy to move that over. That's okay. So this is Confluent cluster. I've got one cluster running. It's running locally. I will share the details of where this is all running. This is also the script that, if you want to use this script, it's running exactly the same thing that I'm going to show you. So essentially, it's called Confluent Platform SIEM, and it's really built around running a few different use cases. The first use case is a Splunk offloading use case. The second one is really around the SIEM, the Sigma stream processor. And then the third one is using KSQL DB to run enrichments and security use cases on top of Zeek DNS type data or Zeek IDS type data there as well. So I'm happy to share this. It's got some great sort of walkthroughs on how to set it all up and some good environment. You can download the Docker instance and get started with that pretty quickly. Once you have got it up and running, we'll go to Control Center. This is Confluent. Control Center is running the kind of the UI for Kafka that's running underneath that. So if I look at my Confluent Control Center, I've got one Kafka cluster running. You can see here that I've got some topics in there. The topics are what I mentioned earlier. This is the log store. This is where the producers will write data into. If I go to connection logs in this particular case and I look at the messages flowing through, there's a range of messages flowing through already. So if I look at this, there's some DNS type logs. So I can see origin host, origin port, all of that sort of information. The value's been split out all nicely, and lots of that information that's flowing through Confluent in this particular instance. And there's a range of topics there. Now, as I mentioned earlier, if I go through and look at the Connect framework, so I will have some connectors running. I mentioned source and sync connectors. So the source connector is actually the Splunk to Splunk source connector. So if I click on this, and then I'll go through some settings just to show you what that looks like. You can see here that it's running on the Splunk port, which is the Splunk to Splunk port, which is 9997 by default. So there's a universal forwarder that's pointing data to this port. And then that is now writing data to this topic called Splunk to Splunk events in this particular case. So that's a source connector. There's also a sync connector. So there's a sync connector that's syncing some data. So these three topics to Elasticsearch there as well. So filtered ASA data, DNS detection data, and then this aggregated data there as well. So that's syncing that data to Elasticsearch in real time. So data coming through, data coming out. What I want to show you next was if I pivot over to KSQL DB, and this is the stream processing engine that I mentioned earlier. So I can see here that I've got some topics that are here on the side. It's quite easy to sort of stream that and use this data. So if I want to just look at some sources, I'll just go, for example, select star from firewalls. And I just want to look at some firewall data coming through. And I'll just make changes. Now, if I click on that, I should see a whole range of sort of firewall data flowing through the system. Give it a sec. We'll see some data flowing through there. Yeah, should be there. Give it a sec. We'll just go to earliest. We'll do that. So maybe there's no data flowing through that right in a second. Okay, there you go. Now, if I pause that and stop that query, there's a range of firewall data. So I can see some Cisco ASA data. I can see some information about it. I've got the location. I've got some information there. Now, if I want to look at, for example, go through and say, let's look at something called, we can search for the IP address and we can do a where clause and run aggregations and do all that sort of stuff. So quite easy to run through that. Now, if I look at how stream processing works, you can see here that I've got a whole range of these select streams running. So I've got some DNS data that's streaming data from the DNS topic that's down there. So a whole range of DNS information there. And I've got the firewall data that's running some firewall stream of information. So I mentioned that earlier, there's the firewall information that's flowing through. Now, what I also wanted to do is aggregate some of this data because some of the firewall data is quite noisy. There's lots of deniers. This particular message ID 106023 is quite noisy, and we want to be able to filter that data within a time span, but also be able to keep the context of there as well. So now if I close that off and then I look at this aggregator topic, you'll be able to see that some of the data now is being filtered and aggregated and counted. So I'll just pause that. And then actually, I'll just open it up here. Now you can see here that I've got this particular firewall message. I can see here that, that it's running a count of this message. Oops, so it's counted this message 19 times. So this particular message has happened 19 times over 60 minutes in this particular case. So instead of sending that message 19 times to the source, what I want to do is I want to count how many times it's happened and send it once, and then give the destination and say it's happened 19 times, but only send it once in this particular case. So that's just a way of aggregating the data. Here's another use case down here as well. This particular message type here has happened 135 times over 60 seconds. So I would send that data once and then just tell the SIEM that it happened 135 times, and then the SIEM can build dashboards around that. Now, if I wanted to pivot over just to quickly look at how we would send that data to Elasticsearch. So if I go to my connect over here, and then I connect over my Elasticsearch sync connector, you can see here that I should already be sending that aggregator topic, the aggregator one that I was sending, and also the raw topic. I'm sending that data over to Elasticsearch. It's quite simple to do. Basically, just you go into Confluent, go all the way up the top where the topics are, and select the topics that you want to send. So let's say I just want to send, I'll send DNS in there as well, just to show you how easy it is to do that. Now, if I go to DNS and I save that, okay, next, and then I'm going to launch that specific sync connector. Then I pivot over to Elasticsearch. So I just have to go through and just create a quick little index pattern over here. So I should have a new pattern here called DNS, which is the one I just saved in that earlier screen. So now I'm going to save that DNS set of information, and I'm going to create a new index pattern called DNS, and you can see all of the fields related to my DNS message that I just synced over from Confluent. So now when I pivot over to my dashboards over here, if I go to DNS in this particular case, you should be able to see that data in real time flowing through to Elasticsearch, which is quite cool. I just did that right there. So great sort of easy way to get data into Elasticsearch. The final thing I just want to show you guys is really around the Sigma processor and being able to run real-time detections on top of the data there as well. So I mentioned there's a couple of engines in here, but if I look at some DNS data in this particular case, we should see some DNS data that's flowing through the system. And there you go, some DNS data in this particular case. So I can see my DNS data, there's some information being written to this log file. Now, if I pivot over to my Sigma rules engine over here, so I mentioned earlier that I can upload a rules process to this particular engine. So now if I go through and say, let's upload a new YAML file, some that I've downloaded from the marketplace. In this case, I'm looking at Zeek DNS exfiltration. So I'm going to open that specific rule. And it's quite simple. It's looking for a service called DNS, but it's looking for anything with a query length between, obviously, the two dots there, the URL that is greater than 180 characters. I might change that. So let's make it 50, just so we can get some hits on that. And then I'm going to publish that Sigma rule. And when I go back to Confluent, this is going to publish that data into a Sigma rules topic. So I'll be able to see that. And then if I look at the message and I look at the last message that just got published, that's the one I just published. So now it's saying, go look at the DNS stream and look for any URL that's greater than 50 characters in length in that between those two dots. And then once it's discovered that, it's going to write the detections into another topic called DNS Detections. And if I go to DNS Detections, I should be able to see some detections here happening as they flow through on my network. Or if I look at the last one here. So there's one that I just pulled out. I had this running a bit earlier as well, but I can see here that this particular query is matching that syntax, and you can see it's greater than that 50 characters of length within that URL. I should probably check out what that URL is. It looks a bit strange, but that's running on my network there, and I can see the origin IP address that's ran that. So being able to run those detections in real time, it writes that to a detection topic. There's a few more there now, and I'm already syncing that topic over to Elasticsearch as well. So I've got DNS detections, and there should be a whole range of these detections that have been picked up in real time over here as well. So now I've got, for example, the AWS URL has been detected as greater than that particular query length. All right. So just to summarize, Confluent is everything from producing and subscribing data into Kafka, and you can do that using the connectors. So whether it's a source or sink connector to be able to pull that data through, KSQL DB to be able to run stream processing on top of that data. There's a whole range of functions to be able to aggregate, filter, enrich, join, parse the data as it's flowing through. And then also to be able to sync that data off into another tool like Elasticsearch there as well. All right, please feel free to reach out or ask any questions along the way. But otherwise, that's I'll open up for questions. But yeah, if you want to learn more, there's a whole range of these use cases, whether it's Confluent.io use cases there on SIEM. I'm happy to share their slides as well. And also, take a look at the developer.confluent.io website. Some great information there. It's got some great information about open source Apache Kafka, how to get access to the clients, how to use Python or Go. Some great event streaming patterns there. Some really good content, some great videos as well in terms of tutorials. And there's also a Confluent Cloud. I think it's the older slide. There's no cost for it anymore, but you can sign up to Confluent Cloud and get no paywall, so no credit cards needed, and you can basically use that for free. I'll open it up to questions, but otherwise, thank you for your time.
Cool, Johnny. Thanks for your wonderful presentation. Demo was awesome. And as I can see in the chat, there is no questions. And yeah, I think it was a wonderful. It was a quite depth, but yeah, I find it's a very useful for as a SIEM point of view. So yeah, any question, guys? Okay, I cannot see any questions. So perfect, I think. And I would like to add some points in the SIEM from the Elastic perspective. So Elastic is also giving the very good solution for the the SIEM endpoint and anomaly detection. Just detect any attacks, any kind of attacks or malware detection, anything. So I just want to quickly, I'll take a minute or 1 minute just to want to share my screen. Okay, cool. Konish, can you confirm, is it visible?
Yes, I can see it.
Perfect. So this is something, the workflow which Elastic Security provides the component. You can see it captures a network monitoring, detect institution detection, firewalls, web proxies, web server logs, anything the Elastic agent used to capture, and it's sent to the Elastic cloud. And on the Elastic cloud, there is an engine who keep evaluating the rules. You can define the policies, you can define the rules. I know it's going to end, but yeah, just allow me one minute. So this is something I'm showing you, the Kibana dashboard, and this is one of the just a short example. It's not completed. In-Ashish, this is my host name. So currently, if you see my terminal, and this is my machine, and I have installed my Elastic agent. So it's collecting the all information regarding my networks. You can say regarding my system metrics and everything. It's sending to the Elastic cloud in the real time. And in the policy, I have made an endpoint -test name policy where you can define your policy, where you can define your rules. And basis on that rules, you can create the different kinds of the alerts here. where you want to, send to the Slack or Discord, anything on the email. So yeah, this is just, I would like to give the short overview of the Elastic Security. Meanwhile, you can go with the, with the detailed documentation where you can go with the anomaly detection with the machine learning. So there is a lots of security solution is already been provided by Elastic. So that's it from my side. But I'll probably try to cover these topic in a brief in the next meetup. So for now, thanks to Johnny to presenting this a wonderful session, and we hope we will again going to catch up in the near future. So over to you, Cornish.
Thank you everyone for joining, and thank you so much, Johnny. That was a fantastic session and it was a great demo as well. We're hoping to have you again at our next session whenever you're available. Thank you. I know Anna is there as well. Thank you for coordinating everything for us. Looking forward to having more sessions with Confluent. And to everybody out there, if you're keen on speaking at one of our meetups, please do write to us at meetup@elastic.co. And you will find the session on YouTube. If you have any questions, you can reach out to Johnny about the presentation. And if you have any Elastic related questions, please reach out to us. And we will see you next time for the next session. Thank you. Bye-bye.
Bye. Have a great day, guys.